Hello, my name is Josh Gurganus, and this is my Lab 1 presentation. So before I start getting into all the details about the lab, I'm just going to give a little information about the background. So this experiment's goal is to show the effects of excess charge by using household objects. For this experiment, I used clear tape to show the effects of excess charge. By using charged pieces of clear tape, you can observe the effects of electric fields and determine the amount of excessive electrons the tape contains. And from using these tapes with excessive electrons, and by measuring the distance that they were pushing on each other, I was able to find the amount of electrons that were on each tape. So the results of the experiment that I found were the tape had a charge of 1.18 times 10 to the negative 9th coulombs, and the tape had 7.39 times 10 to the 9th electrons on it after the experiment. So some observations that I found were that the U-tape was attracted to my hand, and when I had the U-tapes up against each other, I found that they repelled each other. The U-tape was marginally attracted to the plastic ruler, which I used to see how the U-tape interacted with the neutral object. And then I also found that the U-tape was attracted to the pin, and from the experiment we knew that the pin should have been negatively charged. So when I observed that the U-tape was attracted to the pin, I thought that the U-tape was positively charged. However, after the experiment, I found differently. So the measurements, I measured the length of the tape and the mass of the tape. And then the distance between the tapes, that is the two U-tapes. So when I was putting them against each other, I measured a distance of 0.0025 meters. And then I found the magnitude of the gravitational force on the floating tape by doing the mass of the tape times gravity, and then the magnitude of the electric force on the floating tape is the same due to Newton's third law. So we knew the magnitude of the gravity force, we knew the magnitude of the electric force. So my calculations are here to find the electric force and charge of the tape. So the electric force is given here from Coulomb's law. However, since we know the two U-tapes had the same charge, I just rewrote it as Q squared instead of Q1 and Q2. And then to find the gravitational force, we knew it was the mass of the tape times gravity, so I rewrote that there. And then I plugged it all in terms of Q to find the charge of the tape. And once I plugged in all the numbers that I've had so far, I found that Q, or the charge of the tape, was 1.18 times 10 to the negative 9th coulombs. Then I was able to use the charge of an electron, the charge of the tape, to find the number of excess electrons on the tape, which I found to be 7.38 times 10 to the 9th. And then to find the ratio of atoms which gave up electrons, I needed to know the number of excess electrons, because I found the last slide, and then I needed to find the number of atoms on one side of the tape, which I found using the tape's length divided by an atom's length, to be 2.05 times 10 to the 9th atoms. And then the ratio of extra electrons to total atoms I found to be 3.6 to 1. So some assumptions that I used here during my calculations was that I ignored air resistance, and that comes into effect when thinking about the forces acting on the tape. I just wanted to find the electric force and gravitational force, so that's why I ignored air resistance. And also, to simplify the experiment, we treated the tape as if it were a point charge. Also, each U-tape had about similar charges distributed evenly throughout the tape. This aided in thinking about the tapes as point charges, with the tape having an equal and distributed charge throughout the entirety of its body. So here is the glow script at the very top. I went ahead and wrote out all the constants using standard SI units. I have 1 over 4 times pi to E naught, which is Coulomb's constant, and then I had the length of the tape, the mass of the tape, gravity, the distance that I measured between the two tapes, and then the charge in my electron. Next, I denoted the forces, the force of gravity, and then, as I stated earlier, Newton's third law knows that the gravity force and the electric force are equal and opposite, so I used the absolute value tool here to do the opposite direction of gravity force. And then the next part, all the bottom, was denoting the particle of the tape as if it were a point charge. So I have the particle's position written out, and then the equation I did earlier to find Q. And so that was able to print it out here to find Q. And then to find the number of electrons, I just did Q divided by the charge of an electron, Q elect, that I denoted at the top. And then I had it print that out. And then for tape A and tape B, I treated them as points. And then for the two forces, gravity and the electric force, I denoted them as vectors, as you can see here. So the yellow was the tape that I was holding, and then green was the tape that was being floated. The blue arrow, or blue vector, is the electric field, or electric force pushing up against it, and then red arrow is gravity pushing down. So some questions is, what if electrons had positive charge and protons had negative charge? What would change about the observations you made? Thinking about that, since the charges repel and opposite charges attract, this would not really change anything. It's just a matter of denoting what's negative and what's positive. However, the effects on the actual charges would be the same. And why is it important to handle the charged tapes as little as possible? What happens when the charged tape comes in contact with your hands or other objects? And it's important to handle the tape very carefully, because if the tape touches too many other objects, then its charge would be altered by giving away or receiving electrons. So in conclusion, the attractive and repulsive effects of charges on objects were observed in this lab. We also saw that neutral or non-charged objects have a tendency to pick up or give away electrons. Also, we saw that gravitational force and electric force are equal and opposite in order to make the tape float. The distance the U-tape floated allowed for calculating the charge of the tape, and also the charge of the tape allowed to find the number of excess electrons that the tape possessed.